Microchips are like tiny brains for our gadgets. These incredible pieces of technology are the heart and soul of modern electronics, driving the functionality of almost every device we use daily. They're found in almost everything: phones, cars, even toasters. Imagine the complexity and intelligence packed into these small chips, enabling our devices to perform a multitude of tasks seamlessly. These tiny wonders are made of silicon and have millions, even billions of transistors. Each transistor acts as a switch, controlling the flow of electricity and allowing the chip to process information at lightning speed. Transistors are like tiny gates that control electricity, making our devices smart. They open and close at incredible speeds, enabling complex computations and operations that power our digital world. Without microchips, our world would be very different. We would lose the convenience and efficiency that these chips bring to our everyday lives. No smartphones, no laptops, no video games. Our communication, entertainment, and even our work would be drastically impacted. They've revolutionized how we live, work, and play. From simplifying mundane tasks to enabling groundbreaking innovations, microchips are the unsung heroes of the digital age. Believe it or not, the journey of a microchip begins with ordinary sand. Sand contains silica, and silica is used to make pure silicon. First, the sand is heated to extremely high temperatures. This process removes impurities, leaving behind pure silicon. The silicon is then melted and formed into cylindrical ingots. These ingots are sliced into thin, round wafers, ready for the next stage. Now comes the fun part, the magic of creating the tiny, intricate circuits that power our modern world. It all starts with a silicon wafer, a thin slice of semiconductor material. This wafer is the foundation upon which the intricate circuits are built. The process used to create these circuits is called photolithography. It's a fascinating technique that involves using light to transfer a pattern onto the wafer. Imagine shining a light through a stencil onto a special, light-sensitive material. This material reacts to the light, allowing us to create incredibly detailed patterns. The areas exposed to light harden, while the unexposed areas remain soft. This contrast is crucial for the next steps in the process. These soft areas are then carefully washed away, leaving behind the desired pattern on the silicon wafer. This pattern is incredibly precise and forms the blueprint for the circuits. This pattern forms the basis for the microchip circuits. Each tiny line and space is meticulously crafted to ensure the chip functions perfectly. Section 4. Doping giving silicon superpowers. Silicon by itself isn't enough to make a microchip work. It needs a little something extra doping. Doping is like adding spices to a dish. We introduce tiny amounts of other elements to the silicon wafer. These impurities change the way silicon conducts electricity, creating areas that act as pathways for electrical current. Section 5. The grand finale: testing, packaging, and beyond. This is where all the hard work and precision come together to create the final product. The journey of a microchip is nothing short of fascinating, and it all culminates in this crucial stage. After doping, the wafer goes through multiple layers of materials and etching processes to create the final intricate structure of the microchip. Each layer is meticulously added, and the etching process ensures that the pathways for electrical signals are perfectly formed. This step is vital for the chip's functionality and efficiency. Finally, the wafer is cut into individual microchips, each one tested rigorously for quality and performance. These tests are designed to ensure that every chip meets the highest standards of reliability and speed. Any chip that doesn't meet these standards is discarded, ensuring only the best make it to the next stage. The chips that pass are then packaged and shipped off to become the brains of our favorite devices. Packaging is not just about protection, it also involves ensuring that the chips can be easily integrated into various electronic devices. Once packaged, these chips are distributed worldwide, ready to power everything from smartphones to supercomputers. And that's how, from a simple grain of sand, we get the amazing microchips that power our modern world. This incredible transformation is a testament to human ingenuity and technological advancement. Every device we use daily, from our phones to our cars, relies on these tiny yet powerful components. The journey from sand to microchip is a marvel of modern engineering.